In this problem, we again are confronted with a redox reaction that we would like to balance. And I'm going to approach it using the oxidation number technique. So a routine that we now should be fairly familiar with, I go through and I assign oxidation numbers based on the rules we've learned. I then identify what's being oxidized and reduced. In this case, manganese is being oxidized, in which it's going to give up 5 electrons, and bismuth is going to gain 2 and be reduced. As previously encountered, problems like this, we want to make sure the electrons being exchanged are equivalent. We look for a common multiple, and of course 2 and 5 would give me 10. I'll need 2 manganese and I'll need 5 bismuth. So let's go in, put a 2 in front of the manganese ion on the left side and the manganese oxide on the right side, so it takes care of the manganese. And now sweep in and take care of the bismuth. I need 5 on both sides, and those coefficients are sufficient. Now I notice that the oxygens are not balanced. And the way to pick up extra oxygens, again, remembering this is occurring in an aqueous environment, I'm going to add water on the appropriate side. So in this situation, that means I'm going to add extra water molecules on the right-hand side. So putting in the coefficients I've already nailed down, I can see I have 15 oxygens on the left side. I only have 8 on the right side, so I need 7 more, and that's why I need 7 water molecules. But as always, once I put that 7 in there, I also now have added in hydrogens. And this is in an aqueous environment, and we know that this is occurring in water and that there are hydrogen ions in the water. So I'm going to have to add some hydrogen ions to the left side to balance out the hydrogens I've already got on the right side. So putting in the appropriate coefficients, I can see that on the right side I have 7 times 2, 14 hydrogens on the right side. That means on the left side I'm also going to have to get 14, and that's why I put in the 14. So again, do not get thrown by this. Do not get confused like we're just making things up. These reactions occur in aqueous environments, and the species, the ionic species, and the molecules that you know are present in water, they're there during these reactions, and we're just acknowledging them by placing them into our final equation.